First impression of CalculiX. It all started with a simple question. What is a fig file? That tiny curiosity led me toward Xfig, Unix and X11 culture, new GPL, FORTRAN, Sparse Solvers, POSDX, Linux and Windows, HPC, benchmarks, and solver ecosystems. What began as a FEM program exploration slowly became a journey into decades of engineering computation culture. When I first opened the CalculiX repository, the scale immediately stood out. More than 1,000 source files. More than 1,000 example and test files. But the real surprise was not the numbers. Source code. Tests. Examples. Documentation. Verification cases. Build scripts. Everything existed together as one living ecosystem. It felt less like a software release and more like walking into an open research laboratory. Another surprise was FORTRAN. File after file. The old .f extension kept appearing. At first I wondered, FORTRAN? In 2026? But soon the reason became clear. Numerical stability. Sparse matrix operations. Iterative computation. Parallel processing. Cache efficiency. The solver world values different things. And in that world, FORTRAN is still very much alive. Then I encountered the HPC world. POSDX. Paradiso. MKL. OpenMP. Thread. At first they sounded like difficult technical words. Later they felt more like the dialect of solver developers. Their world revolves around speed, convergence, gigantic sparse matrices, Linux optimization, and multi-core efficiency. A place where mathematics, computer science, and systems engineering blend together. But while exploring that world, another question appeared. Is that really the only way? Larger meshes. Larger matrices. More memory. More processors. Real structures do not behave that way. Change begins somewhere. Stress localizes. Relationships weaken. Contact surfaces open. And new space emerges. What if, instead of subdividing everything uniformly, we focused only on the places where change is actually happening? That idea made the direction of HEM even clearer. HEM is not trying to replace FEM. It is not competing with HPC. It is not trying to become a faster solver. Its goal is something different. Hand calculation intuition. Comparative analysis with FEM. Observation of local change. And human judgment at the end. All working together. The one seed direction felt more meaningful than ever. Not a gigantic mesh. Not billions of degrees of freedom. But following change as it is born. Alive and from the inside. That was the clearest lesson from CalculiX. HEM needs to take a different road.